This is the NCFE Level 2 Functional Skills Maths. This is the first of their practice papers, P001269, and we're going to start with the non-calculator section. Activity 1, office move. Emma has been asked to organise an office move. The health and safety guidelines recommend a minimum area of 9.75 metres squared for each employee. Calculate the area required for 27 employees. Okay, let's scroll this up. Now we can see the answer is going to be in metres squared. So if it's 9.75 metres squared for one employee, if we want it for 27, then we're going to need to multiply those together. So we're going to have 975 times 27. Note I haven't put the decimal point in. I find it easy to put the decimal point in afterwards, but if you want to keep it in, that's absolutely fine. So we start off with 7 times 5. So we're going to have 5, 10, 15, 20, 25, 30, 35. So put the 5, carry the 3. Then 7 times 7. Well, we know 5 sevens were 35. So if we carry on from there, we're going to have 42 and then 49 for 7 sevens. Remember to add the 3 to the 49. So that's 50, 51, 52. Put the 2, carry the 5. Then we're going to have 9 sevens. Well, we know 7 sevens were 49. So another 7 will be 56. And another 7 will be 63. That's on 9 sevens. Remember to add on the 5. So 63 plus 5, we're going to have 64, 65, 66, 67, 68. So put the 8 and the 6, because there's nowhere to carry it. Now we're going to multiply everything by the 2, which is in the tens. So we can put a 0 down here. 2 times 5, well, we've got 5, 10. So put the 0, carry the 1. 2 times 7, 7, 14. Plus the 1 is 15. And 2 times 9, we've got 9, 18. Add the 1 is going to be 19. Now we add these two together. 5 and 0 is 5. 2 and 0 is 2. 8 and 5, we've got 13. So 3 carry the 1. 6 and 9 is 15. Add the 1 is 16. So 6 carry the 1. And 1 and 1 is 2. Right, so now all we need to do is put the decimal point back in. So here is where the decimal point was before. So we sort of moved it out, but to get rid of it, we effectively moved it twice to the right to get 975. So we need to put it back into. So if the decimal point starting at the end, we move it once, twice into there. So we're going to end up with 263.25 metres squared. Okay. And if you want to do a bit of a sense check, you can say, well, let's round this. 9.75 is very close to 10. 10 times 27 will just be 270. And this is a tiny bit lower. Okay, question 1b. Let's shift it up so we can see all the question. There you go. Emma is asked to find an office with a floor area of approximately 400 metres squared. She compares 2 office spaces. So office A, with these dimensions here, and office B, which is slightly different shape, but with the dimensions here. The area of office A is 411.92 metres squared. Which office has an area closest to 400 metres squared? Show you're working. Well, for us to know, we first need to work out the area of office B. And then we can compare both numbers to the 400 and see which is nearer. Okay, so, right, how are we going to work this out? Well, this is a bit of an unusual shape, or a compound shape as we call it, where you've got a couple of recognised shapes stuck together. So what I'm going to do, and it's not the only way of doing it, but I'm going to draw a line down here. So what I've created is a rectangle stuck next to, and this shape is in fact a trapezium, because we've got two parallel sides and it's four-sided. So that's our trapezium. If you wanted, you could split it again. So you'd have a rectangle, another rectangle and a triangle, but I'll try and go for the most efficient way. So we've got a rectangle and a trapezium. Now, the area of a rectangle is a length times a width. So we've got the length up here. What we don't know is what that is. But we do know the full width of the whole shape is 24.75 meters. We also know that this bit is 9 and this bit is 4.75. So if we add these two together, we get 13.75. So that means that this length must be the full 24.75 minus these two bits, which are 13.75. So 5 minus 5 is 0, 7 minus 7 is 0, 4 minus 3 is 1, 2 minus 1 is 1. So we've got this is 11 meters. So the area must be 25 times 11. Okay, we could do this the column method again. The way I'm going to do it is I'm going to say, let's put this up here, 10 times 25 is 250. And then to get 11 25s, we'll just add another 25 on. So we end up with 275 meters squared. Now, for the trapezium. So the area of a trapezium, we can do this here, you may recall, is A plus B divided by 2 all times H. Now, what does all this mean? The A and the B are the lengths of the parallel sides. So it's going to be, A is going to be 9, B is going to be this. Well, this is the 9 and the 4.75 together, which we've already seen is 13.75. We'll divide all of that by 2 and then multiply it by H, which is 10. Okay, now this is still the non-calculator section, so we're going to have to work this out ourselves with no help. Well, 9 plus 13 would be 22. And then we can put on the 0.75. We need to divide that by 2 and then multiply it by 10. Right, well, this is the bit we need to do. 22.75 divided by 2. So let's do it with the bus stop method. 22.75. And it doesn't matter that we're putting it into a decimal. We just put the decimal point in. 2 goes into 2 once. 2 goes into another 2 once. Decimal point. 2 goes into 7, 2, 4, 6. So it goes 3 times. Remainder 1. And 2 goes into 15, 2, 4, 6, 8, 10, 12, 14. So that's 7 times. Remainder 1. Let's put remainder 1 up there. Okay. So with this, what we can do is, well, if this is remainder 1, it's 1 out of 2. So in other words, it's a half. So we can make that a 5. If that's not obvious, then what we can do is, effectively we're saying there's an extra 0 at the end. So this remainder 1, I'll get rid of it up there. We'll carry it down there. So 2 into 10 goes 5 times. Right. Hopefully you're right with that. Then we're multiplying our answer. So we want 11.375 times 10. Well, if we're multiplying by 10, we're just going to move the decimal point one place. So we can get 113.75. So let's put that in here. Meters squared. So our total area for Office B is going to be 113.75 plus the 275 for the rectangle. When we're adding them together, it's always good to make sure we've got the same number of digits at the end in terms of decimal places. So 5 plus 0 is 5, 7 plus 0 is 7, put the decimal point, 3 plus 5 is 8, 1 plus 7 is 8, 1 plus 2 is 3. So we've got our two areas. We've got 411.92 and we've got 388.75. We want to know which one is closest to 400 meters squared. So let's shift this up a little bit. So let's start with Office A. How close is it? Well, let's do our 411.92 minus 400. Okay. So 2 minus 0 is 2, 9 minus 0 is 9, 1 minus 0 is 1, 1 minus 0 is 1, 4 minus 4 is 0. So the difference is 11.92. Okay. Now we'll do the same for Office B. Okay. Now we just want the difference because it's saying how close is it. So to make it easy, rather than do 388.75 minus 400, I'm going to start with the bigger number. So 400 minus 388.75. So again, I'm going to put my zeros in, so I've got something to take away from. 0 minus 5, we can't do, so we need to get one from here. We can't, so we need to keep going down the line to try and find one to borrow. So this 4, we're going to reduce it to 3 and pass over 1. This 1, this 10 will reduce to a 9, pass 1 over. Reduce the 10 to a 9 and pass another 1 over. And we're going to have to do this one more time, reduce it to 9, pass 1 over. Okay. Now we can do 10 minus 5, which is 5. 9 minus 7, which is 2. Put our decimal point in. 9 minus 8 is 1. 9 minus 8 is 1. 3 minus 3 is 0. So Office A, the area is 11.92 away. Office B is only 11.25 meters squared away. So that's bigger. So which one is closer? Office B. Right, question 1C. The employer looked at the office plans and held a vote on which office they prefer. A third voted for Office A. Third. 2/5 said they did not mind which office was chosen. 2/5. The rest voted for Office B. What fraction of employees voted for Office B? Well, what we can do is, if we add these two fractions away together, we can then take them away from one, and whatever's left will be the ones that voted for Office B. So we want to do a third plus 2/5. So what we want to do is find a common denominator, because when we're adding, we need the denominator to be the same. Well, 3 and 5, if we multiply them together, we get 15. So that means that 3 and 5 must both be factors of 15. So I'll do the denominators first. 3 goes into 15 5 times, so I multiply the 1 by 5. 5 goes into 15 3 times, so I multiply the 2 by 3, which gives me 6. Now we've got our denominators the same, so that means I can just add my numerators, the numbers on top. So 5 plus 6 is 11. So that is the fraction of voters that either voted for Office A or said they didn't mind. If we want the ones that voted for Office B, then we need, well, what we're saying is we need sort of 1 or 100% minus 11 over 15. Well, one whole, that's the same as saying all 15 out of 15. And then we take away 11 out of 15. Well, because the denominator is the same, we just keep that. And we can do 15 minus 11, which is 4. (1D). 1D. Emma has been asked to estimate the cost of renting an office. The graph shows how the annual cost varies with the total area of the office space. Let's shift this up here. Okay. So we can see, for example, there was one office here that was 100 meters squared, and the cost was, what's that, about 27,000. Another one that was 100 meters squared, and the cost was 29,000. And we can read off the different values for all of these. Now let's see what the actual question is for this one. The annual cost of renting space will increase by 5.75% next year. Estimate the cost of renting a 400 meter squared office next year. Okay, so if we want to know the cost of a 400 meter squared office space next year, our starting point is going to be, well, what does a 400 meter squared office cost this year? So it's 400 that we're interested in, this one here. Now at the moment we've got lots of values here. So when we've got a scatter diagram like this, what we need to do is to draw our line of best fit. So that means it's a straight line going through the data, which follows the overall sort of pattern or trend. So it's going up this way. And we want roughly the same number of observations above as below. So let's try something like, what should we, yeah, something like this. Okay, so I've got quite a few above here, some below. Doesn't matter if it goes through some, so it could be slightly higher, but that's broadly what we're after. So now we're going to read up from 400 meters. Sorry, from 400 meters squared, and see where it. This is quite convenient. It's right there. So if we read this across, it's coming out here. Well, between each of these numbers, 60,000 to 70,000 is a difference of 10,000. We've got 5 little squares. So 10 divided by 5 is 2. So each of these little squares must be 2,000. So 60,000, 62,000, 64,000. This here must be 66,000. Okay. So that's the current annual cost. So this year annual cost equals 66,000. So that's the first part of the question. The annual cost of renting space will increase by 5.75% next year. So now we need to work out what 5.75, sorry, you can't see that. Need to work out what 5.75% of 66,000 is, and then add it on. Okay, I'm going to split it up. So I'm going to say 5.75% is the same as 5% plus 0.5 or 0.5% plus 0.25%. If I could use a calculator, I'd do it just all in one go. But without a calculator, this is going to make it easier for me. So what is 5% of 66,000. Okay, well, I know that 10% of 66,000 would just take a zero off. So it'd be 6,600. So 5% will be half of that, which would be 3,300. Now, if I want 5%, sorry, I've got 5% of 6,600. I want 0.5%. Well, 0.5 is 1/10 of 5%. We can see the decimal point, we're just moving it once. To get from 5%, we move the decimal point 1 to the left to get 0.5%. So we can do the same thing with this. So 0.5% of 66,000. If our decimal point's here, we're going to move it once. So we'd end up with £330. Now all we need is the 0.25% of 66,000. Well, 0.25 or a quarter, well, that's half of 0.5%. Okay, because it's like, yeah, a quarter is half of a half. So we want half of 330. Well, let's do it over here. So 330 divided by 2. 2 goes into 3 once, remainder 1. 2 goes into 13, 2, 4, 6, 8, 10, 12. So that's 6 times, remainder 1. And 2 goes into 10, 2, 4, 6, 8, 10, 5 times. So 0.25% of 66,000 is 165. So if we add all of those together, 0, 0, 5 is 5, 0, 3 and 6 is 9, 3, 3 and 1 is 7, and we got 3,000. So that is 5.75% of 66,000. Now we need to add on the 66,000 because they're asking us what the cost will be. So that's including that increase. So add those together. So 5 and 0 is 5, 9 and 0 is 9, 7 and 0 is 7, 3 and 6 is 9, 6 and nothing is 6. So that's our final answer. 69,795. Final question. Emma gets the quote for office furniture. Okay, so we've got to supply and install the furniture. We've got how much the desks cost, the chairs, the filing cabinets, meeting table, 12 meeting chairs, delivery and installation, and the total price. What fraction of the quote is for delivery and installation? They're asking us the fraction of the quote, so that's the total that we're interested in, and delivery and installation. So we don't care about all of this other stuff. Yeah, not of interest. So it will be 1,875, because that's the delivery and installation cost, as a fraction of the quote. So divided by or over 18,500. That's our fraction. Now, that is correct, but it's not in its simplest form. We can reduce this down or simplify it. So what we're going to do is say, well, what number goes into both of these? Now, there's some larger numbers, but it's not always obvious what's going to work. But if we know that a number ends in 5, then it must have 5 as a factor. If we know a number ends in 0, well, then we know 10 is a factor, but also 5. So I'm going to divide both numbers by 5. You might find this is a long way of doing it. So if you know a shortcut or you can see larger factors, that's absolutely fine as well. So 5 into 1 doesn't go. 5 into 18 goes 3 times remainder 3. 5 into 37, 5, 10, 15, 20, 25, 30, 35 goes 7 times remainder 2. And 5 into 25, 5, 10, 15, 20, 25 goes 5 times. So we get that this is equal to 375. And how many times does 5 go into 18,500? 5 into 1 doesn't go. Again, 5 into 18 goes 3 times. Carry 3. 5 into 35, we saw before that that goes 7 times with no remainder. 5 into 0 is 0. 5 into 0 is 0. So we get 3,700. Now we can reduce this again. What you might see is that because we've got 75 and this is got 100 as a factor, we could divide by 25. But I'm going to carry on dividing by 5 again because we've got a 5 and a 0 again. So let's do 5 into 375. 5 into 3 doesn't go. 5 into 37 we've already seen goes 7 times, remainder 2. And 5 into 25, 5, 10, 15, 20, 25, 5 times. So we get 75 on top. And now we want 5 into 375. Well, 5 into, not into 375, sorry, 5 into 3,700. Otherwise I'd be doing the same thing. Well, we saw 5 into 37 goes 7 times, remainder 2. 5 into 20, 5, 10, 15, 20 is 4 times. And 5 into 0 is 0. So we get 75 over 740. As I said, this is a long way of doing it, but it works. Okay, so what we can do, we've still got a 5 and a 0. Let's divide it by 5 again. Okay, so 5 into 75. 5 into 7 goes once, remainder 2. 5 into 25, 5, 10, 15, 20, 25. It's 5 times. And 5 into 740. So we're dividing top and bottom by 5. 5 into 7 goes 1, remainder 2. 5 into 24, 5, 10, 15, 20. So that's 4 times, remainder 4. And 5 into 40, 5, 10, 15, 20, 25, 30, 35, 40. That's 8. So we end up with 15 over 148. And you can try, but that won't go any simpler. And finally, 1F. Another option is to rent a fully furnished office. Prices vary according to the length of the rental period. So for a 1-year rental period, it's £10,000 a month. For a 5-year rental period, they pay £8,500 per month. Calculate the percentage discount per month if the office is rented for 5 years rather than for 1 year. Well, all of these figures are per month, which is fine. So what's the percentage discount? Well, first of all, let's work out what the actual discount is. So 10,000, take away 8,500. 0 minus 0 is 0, 0 minus 0 is 0, 0 minus 5 we can't do, so we need to borrow this. So the 1 goes and put it there, the 10 reduced to a 9 and carry 1 over. So 10 minus 5 is 5, and now we've got 9 minus 8, which is 1. Okay, so that means we have got the percentage discount is going to be 1,500 divided by the original price, sorry, the original price, which was 10,000. And because we want to make it a percentage, we will then multiply it by 100. Right, so lots of zeros, so we can do some cancelling. So we're multiplying by 100 here. So because we're dividing, we can cancel 2 zeros up here with 2 up here. We've still got 2 zeros here and 2 down here, so we can cancel another. So it's like we're dividing and multiplying by the same number of zeros. We end up with 15 over 1, which is the same as just 15 It's the NCFE Level 2 Functional Skills Maths first practice paper. So that's P001269. And this is the second section, so you can use your calculator. Activity 2. Films. Liam downloads films from the internet. The table shows the number of films he downloaded last month. So we've got these split between action, comedy and sci-fi with a total, and whether they were less than an hour long, exactly 1 hour long, more than an hour, and then the total for each of those. He chooses one of these films at random. What is the probability that the film he chooses is an action film that is at least 1 hour long? Right, when it's probability, it's always good to start off with the denominator. We've got 28 films in total. So he's selecting from those 28 films. And we want the ones that are an action film, so it's going to be in here, at least 1 hour long. So if it's at least an hour, that means it could be exactly 1 hour or more than 1 hour. So 2 and 1, 3. 3 over 28. And we can leave our answer like that. 2b. I'll have to move it down for the question. Liam thinks he might watch either Rainbow Prism or The Infinity Zone. He looks at the scores given by different newspapers. The scores are out of 100. Okay, so Rainbow Prism got, from the Daily Times, it got 75 out of 100. From the London Post, it got 63 out of 100. And all of these others. And for The Infinity Zone, these are the scores that film got. Which of the two films would you suggest Liam watches next? Use 2 appropriate statistical measures to explain your answer. Okay, well, what statistical measures can we use? Well, we can use an average. And the different averages that we've got, well, we've got the mean, the median, and the mode. The mode probably isn't going to help us because all of these scores are different. So we could use the mean and the median, okay, as our 2 statistical measures. You could also use the range, but I'm not going to do that here, okay. Although it's not an average, it is a statistical measure if you wanted to use the range. So let's shift this up and let's do the mean first of all. Okay, so we're going to have rainbow and we're going to have infinity. So if we want to work out the mean, well, we need the total, so adding them all up, and divide by how many, or the frequency. So let's add up all of these scores for Rainbow Prism. 75 plus 63 plus 52 plus 38 plus 70 plus 83 plus 60 plus 41 and plus 52. So I get 534. And how many have I got? 1, 2, 3, 4, 5, 6, 7, 8, 9. So 534 divided by 9 gives me 59. I'm going to round that. Let's call that 59.33. Or we can put a recurring. Now for the infinity zone, let's do the same thing. 75 plus 68. This one was not scored, so we'll just leave that blank. Plus 50, plus 74, plus 65, plus 79, plus 40, and plus 63. And we get 514. And we've got 1, 2, 3, 4, 5, 6, 7, 8 this time. If the City Observer had scored it 0, then I would include it. There would be 9 of them. But because it hasn't given a score, I'm not going to include it, so I've only got 8 of them. So 514 divided by 8, and we get 64.25. Okay, so that's our mean. I also want to work out the median. Now, for the median, we want the middle number. So, should we do it like this? So median. So for the daily times, I'll do this. I'm going to write out these scores from smallest to largest. So what's the smallest? We'll do 38 first. We'll number them. And what's next? Then 41. Then next comes 52. Then another 52. Oh, we could have used the mode, but it wouldn't really make a lot of sense because this is the only score that's we've got more than once. So what's that? 52. 52. Then the next biggest number is 60. So that's number 5. Then 63. That's the 6th. Then we've got 70. Then 75, and then finally we've got 83. So to work out the median, we cross off the smallest and the largest. Next smallest, next largest. We keep going until we're left with 1. So we've got a median of 60. Now for the infinity zone, we could do something similar. I'm going to order them first of all. So the smallest is 40, then 50, then we've got 63, then 65, then 68, then 74, 75, then 79. So if we've got 8 numbers, another way of thinking of it is, well, what's the middle of 8? Well, halfway between 8, well, half of 8 is 4. But if you think, if we've got 1, 2, 3, 4, 5, 6, 7, 8, halfway between them would actually be between the 4 and the 5. So we want halfway between 4 and the 4th and the 5th value. So we're going to want the 4th, which is 65, plus the 5th, which is 68, and then divide those by 2. So when you've got an even number of values, for your median, you're going to need to add the 2 middle ones together. Make sure you press the equal button first, and then divide by 2. Pressing the equals button after the 65 plus 68 is especially important if you're using a scientific calculator. If you don't press the equals button first and you just do divide by 2, you'll get the wrong answer. Okay, give it a try. Right, so which of the 2 films would you suggest? Well, Infinity has got a higher mean, and it's also got a higher median. So I would go for Infinity Zone. (2c). Screen images are made up of units of light called pixels. And we've got pixels per square inch, or PPI squared, is a measure of image quality. PPI squared equals n over a, or n divided by a, where n is the number of pixels and a is the area of the screen in square inches. Liam's old screen has a PPI squared value of 9,800. He wants to buy a new screen with a better image quality. Liam sees a rectangular screen that has a width of 101.6 centimetres and the width to height ratio, and a width to height ratio of 16:9. It's also got 8.28 million pixels. He works out that this will have a better image quality than his old screen. Is Liam correct? Show your working. And use the conversion of 1 inch equals 2.54 centimetres. Okay, so, well, we've got our formula up here. PPI squared equals N over A. Well, we know that N is the number of pixels. And they have told us that the number of pixels is 8.28 million. Or 8.280,000. To write it out in full. Now, for the area, we know that we need to multiply the width by the height. We know the width. We don't know the height, but we do know the ratio. Okay, so what we can do is we can say, well, the width to height ratio is 16:9. We know that the width is 101.6. So what we want to do is find out, well, what's our sort of multiplier? How do we get from 16 up to 101.6 in terms of multiplying? So if we do 101.6 divided by 16, we will get 6.35. So if we multiply our 9 times 6.35, that will give us our height, which is 57.15. Okay. We want the area in square inches. At the moment we're in centimetres, so we want to convert both of these. We want to convert both of these into inches. Well, if there's 2.5 centimetres in each inch, we're going to need to divide this by 2.54 and divide this by 2.54. If you're not sure which way to do it, think, well, inches are bigger than centimetres. So if we've got the answer in centimetres, the answer in inches will be smaller because we're going to have fewer of them. Okay, so let's do the 101.6 divided by 2.54, and we get 40 inches. And if we do the 57.15 divided by 2.54, we get 22.5 inches. So our area, which is length times width, is going to be 40 times 22.5, which is 900. Now we can use our formula up here. So we know the number of pixels was 8,280,000. Our area is 900. We could cancel some zeros, but we've got the calculator, so let that do all the work. 900, and we get 9,200. Now that is less than the 9,800 that they've given, so it must have a lower quality. So he works out it will have a better image quality. Is Liam correct? No, he's not. (2D). Liam searches for a choice of broadband services. He finds this graph. Let's show the graph in full. Good. Okay, cost of broadband services. So this is the cost per month, and this is the advertised broadband speed. So for example, with A, they say it's got a speed of 10 MBS, which we're told is megabits per second, and the cost per month is £16. If we pick another one like M, they tell us that it's got a speed of 110 megabits per second, and the cost is, well, it's halfway between 42 and 43, so it'd be £42.50. So yeah, they said broadband speed is measured in megabits per second. The lettered crosses in the graph represent the different services. What is the modal speed of these broadband services? So modal. So that means which one is the most, and it's the modal speed. So these are all our speeds. Which one have we got the most of? Well, we've got 3 of them with 10 megabits a second. We've got 4 of them with, it's halfway between 30 and 40, so that's going to be 35. Then 1 and 1, 3 there, 1, 1. So this is going to be the most. So the modal speed would be 35 megabits a second. Now, they say using the graph from 2D, what percentage of these broadband services cost over £25 per month? Give your answer to 2 decimal places. Right, so let's go back here. So we want, let's check the question. What percentage are over 25 per month? Right. So I'll do it here. Percent over £25 per month. That's what we're trying to find. Well, how many have we got altogether? If we start off with it as a fraction. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And we want the ones that cost more than £25 per month. So there's 25. So it's all the ones above that line. 1, 2, 3, 4, 5, 6. So 6 over 14. To turn it into a percent, we multiply by 100. $42.85714. They wanted it to 2 decimal places. So the first 2 decimal places are 85. But we look at the third place. The 7, it's more than 5. So we need to round this 5 up. So we're going to get 42.86%. And that's our answer. So that was the answer for E. Now for 2F. This is the graph in 2D. I'll shift it up so we can see it again. Yeah, exactly the same. The actual speed of a broadband service depends on how far the customer's house is from the nearest connection box. So if they're between 0 and 100 meters from the connection box, they get the full 100% of the advertised speed. If they're between 101 and 500 meters away, they only get 85%. And if they're between 501 meters and 1,000 meters, they get 70% of the advertised speed. And the question is, Liam's house is 350 meters from the connection box. Liam wants to download a 7,000 megabit film in less than 2 minutes. What is the cheapest broadband service he can choose? Right, so 350 meters, 7,000 megabits, and 2 minutes. So if he lives 350 meters away, that means he's going to get, he'll be in this one, so he's going to get 85% of the advertised speed. Okay, so that's 350 meters, 85% speed. Okay, what are we going to do? So we can have a look at our graph. Oh no, he wants to download a film. Let's look back. A 7,000 megabit film. in less than 2 minutes. Well, if we know how many megabits per second there are, that means that we need to download the 7,000 megabits in 120 seconds. Because that's going to be 2 minutes. Okay. So we're going to work out the speed. So 7,000 megabits we need altogether. So 7,000 divided by 120. We need 58.33 recurring megabits per second. Megabits per second. Let's use the same notation as that. Right. But he's only going to get 85% of the speed. Right. So this, he actually needs an advertised speed which is higher than this. So if we take the 58.33, what we need to do is divide it by 85% to find out what 1% is of what we need, and then multiply it up by 100. So I've still got the 58.333 in my calculator. So if we divide that by 85 equals, multiply it by 100, we are going to need a speed of 68 around its 2 decimal places, 0.63 megabits per second. That's what we need as the advertised speed. Okay, so, and we want the cheapest one. So 68.63, well, 60, these are going up in 2, so 62, 64, 66, 68. So basically it's going to be everything beyond that line. So it's going to be J, K or L. And the cheapest one is this one at the bottom. And they don't ask us how much. They just ask us, if we look back here, which is the cheapest broadband service you can choose. So it will be J. So lots of flipping back and forth on the paper. Hopefully in the exam you'd have those two next to each other, so it's a bit easier for you to see it in one go. Activity 3. Building a pond. Aria is involved in a community project group. The group are planning to build a pond in the garden of a local hospital. The pond has a path around it. On a scale plan, the width of the path is 6.7 centimetres. The scale on the plan is 1 to 25. Calculate the width of the path. Well, if it's 6.7 on the plan, so on the drawing, the scale is 1 to 25. That means for every 1 centimetre on the plan, it's going to be 25 centimetres in real life. So we just need to multiply that by 25. And we get 167.5. The pond will be a cuboid. It will be lined with a sheet of plastic pond liner. The pond liner covers the bottom and sides of the pond. The pond liner needs to be cut to this shape to exactly fit into the pond without any overlaps. So this is the shape it needs to be cut into. The dimensions of the pond liner are shown in this diagram, so we've got it here. Okay. And we're told sheets of pond liner are available in these sizes. Okay, we'll keep it there so we can see the pond liner. But I'll turn over for the question, which says, Aria needs to buy the cheapest pond liner that is big enough to fit the pond. Which pond liner should she buy? Right, okay. So, well, we want to know, they are just telling us in the width and the length. So we don't really care about these corners cut out. We need the full length. We need to know what this is. That length. And that is going to be our 7.65 plus 0.72 here, but also plus another 0.72 there, which gets us 7.65 plus 0.72 plus another 0.72, 9.09 meters. And if we look at the width, so here to here, this is going to be 4.38 plus a 0.72 and plus another 0.72. So 4.38 plus 0.72 plus another 0.72, we get 5.82 meters. Right, so now we're going to have a look at the sheets we've got. It needs to be at least 5.82 meters wide. So that one's no good. That one's no good. These are all more than 5.82, that's fine. It needs to be at least 9.09 long. All of these are. We want the cheapest one. So that's going to be this one here. Okay, so that's just going to be liner C. Now, the group asked Aria, let's get it straight. The group asked Aria to buy chemical treatment for the pond water to make it suitable for fish. One bottle contains enough chemical to treat 1,300 gallons of water. And we're told that 1 metre cubed is equal to 220 gallons. Aria adds water to the pond until it is 92% full. How many bottles of chemical treatment will she need? Okay, well, so first of all, we want to work out how much water we're going to need. So that means we want to work out the volume of the pond. Now, if we work out the volume of the pond, that will be when it's full, but we actually only want 92%. So let's start off by working out that full volume. So the volume. And the volume is worked out by the length times the width times the height. Now, what I'm going to try and do is do a little sketch of our pond. They said it's a cuboid, so it's going to be something like, which way are we doing this? Something like that. Okay, so here's our height, here's our length, and here's our width. Well, if we look back at our picture from before, the length, now the length we're interested in is not the full length, because that includes, so these bits are going to fold up, these side bits. Okay, these are actually going to be the sides. Yeah, we've got a side there, we've got a side there, we've got a side there, and we've got a side here. So for the actual cuboid, the length is going to be this bit inside, which we were told was 7.65 meters. Okay. And the width, well, the width is going to be this bit here or this bit here, 4.38 meters. And the height, well, the height is going to be these side bits which are folding up. So we're going to get 0.72 meters. So we need to multiply these all together. So 7.65 times 4.38 times 0.72. and we're going to be dealing with meters cubed, so we keep everything in meters, and we get 24.125. I'll put all of them in, and that's going to be meters cubed. Right. Now, we're dealing with gallons, so we need to convert our meters cubed into gallons. So if 1 meter cube is 220 gallons, or 24.12504 meters cubed need to be multiplied by 220, not 222. And I've still got that number in my calculator, so it doesn't matter if I rounded it on the paper, as long as I keep all the numbers there. Multiply it by 220, and we get 5,307.5088, and that is gallons. Okay. Now, we don't want all of that. We only want 92% of it. So we can multiply it by, well, 92% would be 92 over 100, which as a decimal is 0.92. So times 92 divided by 100, and we get 4,882.908 gallons. That's what we need. Now, each bottle has got 1,300 gallons. Is enough to treat 1,300 gallons. So we want to know how many of these bottles go into the 4,882. So if we do 4,882, sorry, it's all been chopped off, 0.908 divided by 1,300. This will tell us how many bottles we need. And we get 3.756. I'll round that for now. You can't buy 3.756 bottles, so we'll have to need 4 bottles to buy. So now, question 2D. Aria needs to work out how many fish can be put in the pond. She wants to have both koi fish and goldfish. The number of fish is based on the surface area of the water in the pond. Koi fish need 1.2 meters squared each. Goldfish need 0.6 meters squared each. Aria wants to have a mixture of koi fish and goldfish in the ratio 1:4. So for every 1 koi fish, she's going to have 4 goldfish. What's the maximum number of koi fish and goldfish that Aria can put in the pond if she keeps the ratio 1:4? Okay. Well, we're talking about surface area. So it's a cuboid. So the surface, a very good picture, is just going to be a rectangle. I don't know why I've drawn it 3-dimensionally, but that's not a problem. And we know from before, if we go back to the original picture, that the length was 7.65 and the width was 4.38 meters. So the surface area is going to be the area of all of this. So the area is going to be 4.38 times 7.65, which is 33.507, and that's going to be meters squared. Okay, now we know that we've got this ratio here of what have we got? For the koi fish need 1.2 meters squared each. So let's do a little table. Koi and gold. Okay. So the koi fish need 1.2 meters squared. Now for the goldfish, well, we actually need, although we need 0.6 meters each, for every one koi, we're going to have 4 goldfish. So 4 times 0.6 is 2.4. Okay. So every time we have one koi fish that needs 1.2 meters, we're going to have 4 goldfish which need 2.4 meters squared. So that means in total, 1.2 and 2.4, these fish are going to need 3.6 meters squared. Now, we know we've got a total of 33.507 meters squared that we can use. So if we do our 33.507 divided by 3.6, that'll tell us how many sort of sets of these koi and goldfish we can have. So 33.507 divided by 3.6 is 9.3075. But we have to keep the ratio the same. So we can't have sort of part of a set. So we're going to have to just have 9. So that means we're going to have 9 koi fish. But remember, with the goldfish, for every one koi, we've got 4 goldfish. So we need 4 times 9, which is going to be 36. Now, 3e. The group need to build a ramp between the hospital door and the gardens. The angle of the slope of the ramp must not be more than 5 degrees. Calculate the angle of the slope. Well, we've got this here. This is a right angle, which is 90 degrees. We've got 86 degrees here. I know that the total angles in a triangle 180 degrees. So if we add these together, and then take them away from 180, the difference must be the angle of this slope, 4 degrees. It's 1 mark, so we know it's going to be a nice, quick and easy question. Shouldn't say easy, straightforward. Okay, the diagram shows the measurements of the ramp. Draw the plan view as the ramp as seen from above. Include the dimensions on your drawing. Right, so if we're looking down onto this, we will see the grey bit, but we won't see that it's sloped. We'll just see it as a rectangle. We will see that it is 0.8 meters across. And it's not a scale drawing, so I'll just draw it as a rectangle. How long is it? Now, don't be fooled into thinking we need that length. If you're looking for it directly down, we're only going to see that it is 12.88 meters. There we go. (3G). The group need to order enough concrete to make the ramp. The formula to find the volume of a triangular prism is L, which is what that shape was. If we go back, this is our triangular prism because it's a triangle here, and it's the same shape. The cross section is the same all the way through. The formula to find the volume of a triangular prism is L times H times W, all divided by 2, where L is the length, H is the vertical height, W is the width. Calculate the volume of concrete that's needed to build the ramp. Well, the length was 12.88. that was this length here. The width is 0.8 and the height is 0.9. So we've got 12.8. Oh, they had the height next, didn't they? It doesn't matter. We'll do the 0.9. And then the width, which is 0.8. And we're going to need to divide that by 2. So 12.88 times 0.9 times 0.8 gives us 9.2736 divided by 2. So let's divide it by 2. And we get 4.6368, and that is going to be meters cubed, which is what we've got down there. Activity 4. Saving energy costs. Eli needs to complete a project on energy costs for his college course. Eli's family currently use X-Power for gas and electricity. They pay monthly by direct debit. X-Power use the median monthly cost for January to June to set the amount of their monthly direct debit payments for July to December. The graphs show the energy costs for last year. Okay. This is what they used. The blue bit is for the gas and the red bit is for the electricity. Okay. Now, if you want to know how much they use for electricity, you can't just take that total, you'd have to subtract the gas bit, because this would be the total cost for both of them. Eli works out that they have paid too much between July and December. Calculate the percentage by which they have overpaid. Right, okay. Now it uses the median monthly cost. This is what we've got here. And the median monthly cost for January to June. So let's work out what the median cost is. Okay, well, it's on the total that we're interested in. So the median is the middle one. So this is the smallest. I mean, these two are the same, but this is the smallest, this is the largest, this is the next smallest, next largest. So it's good. These are the two middle ones. So we've got this measurement, and these are going up in fives, I think, 130, 135, 140, 145. Yeah, so we've got 145 there, and this one is going to be 155, 160. So the median is going to be 145 plus 160 divided by 2. Remember to press the equals first, divide by 2, and we get 152 pounds 50. Okay. Now, he's talking about them paying too much between July and December. This is just for 1 month. If it's July to December, that's 6 months. So if we multiply that by 6, we should get the total cost for 6 months. So the company has estimated that they need to pay £915 for July to December. How much did they actually have to pay? Well, now we're going to have to work it out from here. So for each month. So if this is 50, 55, 60, 65. August is the same as July, so another 65. September, that's an easy one, that's 100. October, so here, so 150, 155, 160. November, well, if this is 175, we've got 180, 185. And December, we've got 200. So the total, 65 plus 65 plus 100 plus 160 plus 185 plus 200 gives us £775. Now, the actual question said, Eli works out that they have paid too much between July and December. Calculate the percentage by which they have overpaid. Right, well, we had £915 that they paid, and they should have paid £775. So that is a difference. We can use our calculator. Of £140. The percentage by which they've overpaid, well, it's going to be 140 over the amount they have paid, and then to turn it into a percentage, multiply by 100. So 140 divided by 915, and then multiply it by 100, gives us 15. We'll round it to one decimal place. 15. Oh, no. How much have they overpaid? So we need to compare this, my mistake, by the amount they should have paid. Right, almost got that one wrong. We need to read the questions carefully. That includes me as well. So, £140 is the amount they overpaid. They should have only paid £775. So that's the one we want at the bottom. So 140 divided by 775, then multiply by 100, and we should get 18.06%. Okay. Good example of why you shouldn't rush these questions, because I nearly got that one wrong. Okay. 4b. This is Eli's electricity bill for the first quarter of this year. VAT is calculated after discount. So total electricity used was £211.90. Dual fuel discount, so that's if you have electricity and gas with the same company, you save £14.90. VAT was £9.85. The total including the VAT was £206.85. Yeah, VAT is calculated after the discount. That's this discount. What percentage has been used to calculate the VAT? Right, so we know that £206.85 includes the VAT. Okay. We want to work out what it is without it. Well, let's start by taking off this discount. So that's including VAT. Okay, if we do £211.90 minus £14.90, we get £197. Okay. Now, the VAT was £9.85. So we want to know what that is as a percentage of the amount they paid it on. So because it's a percentage, again, we're going to need to multiply that total by 100. So 9.85 divided by 197 times 100, and we get 5%. C. X-Power offer a loyalty plan. The formula X-Power used to work out the cost for the loyalty plan is D times 365 plus P times G, where D is the daily charge in pounds, P is the price per kilowatt in pounds, G is the gas used per year in kWh, kilowatt hours. For this plan, the charges are daily charge of 32p, and the price per kilowatt hour is 3.10p. So note, these are in pounds, but these are in pence. Last year, Eli's family used 17,563 kilowatt hours of gas. This cost £719.38. Should Eli's family choose the loyalty plan for their gas? Excuse me. Show you're working. Right, so let's use this formula. D is the daily charge in pounds. Well, 32p in pounds is 0.32. Then we're multiplying that by 365. Then we're going to add that to the price per kilowatt hour in pounds. So 3.10p, to turn it into pounds, we need to move that decimal point twice. So it's actually going to be 0.031. You can put the 0 on the end if you want. And that's times the gas used, which was 17,563. So we get 116.8 plus 544.453. Add those together and you get 661 point, and it's money, so we just round it to 2 decimal places. Okay, now that is less than what they paid. So should they use the loyalty plan? Yes. The average UK gas bill is 3.875 times more than the average UK electricity bill. Write 3.875 as an improper fraction. Okay, so best way to think of this is to move that decimal point so that we haven't got a decimal anymore. So we need to move it 1, 2, 3. So that's the same as 3875 over 1000. Okay. And we can leave it like that. It doesn't ask to have it simplified, so you could simplify it if you wanted, but I'd probably just leave it like that. Write 3.875 as a percentage. Okay, well, it's just going to be 3.875 multiplied by 100, which always looks weird because this is more than 1. Normally, if we had 0.5 multiplied by 100, it makes 50%. That makes sense. But this looks a bit weird. But it's still fine. It's still the same thing. Multiply it by 100, so we're going to move that decimal point twice, or do it on your calculator, and we get 375.5%. And the final question. Eli looks for information on the cost of leaving gadgets on standby when they are not being used. Eli's gadgets are a TV, computer, printer, phone charger, and 2 games consoles. He finds several reports stating how much electricity a gadget uses when left on standby, but they do not agree. So the annual saving, they're saying that it's between nothing and £4.99. One report says that. 4 reports say that the annual saving is between £5 and £9.99. 5 reports say it's between £10 and £14.99. And 2 reports say it's between £15 and £19.99. Use an estimate of the mean to find out how much money Eli could save if he switched off his gadgets instead of leaving them on standby. Right. Now this estimate, usually when we see estimate we think of rounding. But with this, the estimating is to do with these bits. Now the annual saving per gadget, we don't know exactly what the saving is. So we need to just make a sort of a reasonable assumption. And that reasonable assumption is to say, well, between 0 and £4.99, let's assume that it's right in the middle. Okay, so halfway between 0 and £4.99. Now, you could add them together and divide by 2. We're doing something very similar, but halfway between 0 and 4. Well, yeah, let's do it that way. So we do 0 plus £4.99 is just £4.99 divided by 2, 2.495. We need it to 2 decimal places because it's money, so it's going to be £2.50. Or you might be able to see that halfway between 0 and £4.99 is £2.50. Let's do it the full way again for this. So halfway between 5 and £9.99, we add them together, divide by 2, 7.495, but because it's money, we need to round it up to £7.50. So you can carry on, or you might be able to see the pattern that this is going to be £12.50, and this one halfway between will be £17.50. Now there's one report that uses this midpoint, so we don't need to use these ranges anymore. We can just use our midpoints. We had one report with this value, so if we multiply it together we get £2.50. There were 4 reports saying that it was this value. So £4 times £7.50 gives us £30. 5 times £12.50, you can use your calculator, but I'm pretty sure that's £62.50. And 2 times £17.50 gives us £35. Now, we want an estimate of the mean. And we know that the mean is the total divided by how many, or the frequency. Well, our total is going to be all of these values added together. So our £2.50 plus 30 plus £62.50 plus 35 is £130. And how many have we got? Well, 1 plus 4 is 5, plus another 5 is 10, plus another 2 is 12. So we're going to do 130 divided by 12, which gives us 10. We need it as money, so round it to 2 decimal places. 3 is less than 5, so 10.83 or £10.83. Now, we did say that this is how much electricity a gadget uses. Well, how many gadgets has he got? He's got 1, 2, 3, 4, and 2 games consoles, so 5, 6. So we need to multiply this by 6, because that's just the saving for one gadget. Multiply it by 6. And I haven't rounded that because we want the exact answer. We'll get 64.99999, which we can round to £65. And that is the end of the paper. Okay, so I hope that was helpful. Please like, add any comments, ask any questions that you've got. If you haven't already, subscribe to the channel. That way you'll get notified when I add more videos. And I hope to see you all again soon. Thank you.